This video covers functions and transformations for A-level pure maths, starting with function notation and working all the way through to combining transformations. It follows the same two-part structure as always, a full worked process first, then a simplified recap at the end. A function, written f of x, takes an input x and produces exactly one output. The domain is the complete set of x values you are allowed to put in, and the range is the complete set of values that come out. Take f of x equals x squared for x greater than or equal to 0. On the graph, the domain is read along the horizontal axis. Here it is x greater than or equal to 0, and the range is read along the vertical axis. Here it is f of x greater than or equal to 0, since the curve never dips below 0. Now, composite functions fg of x means apply g first, then apply f to the result, so you work from the inside outwards. Let f of x equal 2x plus 1, and let g of x equal x squared. Then fg of x equals f of g of x, which is 2 times x squared plus 1. To evaluate fg of 3, first find g of 3, which is 3 squared equals 9. Then apply f to that result. F of 9 equals 2 times 9 plus 1, which equals 19. So fg of 3 equals 19. Now inverse functions, f inverse of x undoes what f of x does, but a function only has an inverse if it is 1 to 1, meaning every output comes from exactly one input. To find an inverse algebraically, start with y equals f of x, swap x and y, then rearrange to make y the subject again. For f of x equals 2x plus 1, write y equals 2x plus 1. Swap the letters to get x equals 2y plus 1. Rearranging, subtract 1 from both sides to get x minus 1 equals 2y, then divide by 2, giving y equals the quantity x minus 1 divided by 2. So f inverse of x equals the quantity x minus 1 divided by 2. Notice that f of x equals x squared over all real numbers is not 1 to 1, since f of 2 and f of minus 2 both equal 4. Without restricting the domain, that function has no inverse. Before we reveal it, predict this. If you plot f of x and f inverse of x on the same axis, what do you expect to see about how the two graphs relate to each other? The graph of f inverse of x is always the reflection of the graph of f of x in the line y equals x. Plotting f of x equals 2x plus 1 alongside f inverse of x equals the quantity x minus 1 divided by 2, the two lines are mirror images across that diagonal line. Now the four basic transformations, using f of x equals x squared as the starting curve in each case. First, f of x plus a is a vertical shift. Taking a equals 2, f of x plus 2 equals x squared plus 2, and the whole curve moves upward by 2 units. Next, f of x plus a is a horizontal shift. Taking a equals 2, f of x plus 2 equals the quantity x plus 2 squared, and the curve moves left by 2 units. Watch out here, a positive number inside the bracket shifts the graph left, not right. Next, a times f of x is a vertical stretch. Taking a equals 2, 2 times f of x equals 2x squared, and every point on the curve moves twice as far from the x-axis, so the curve stretches vertically by scale factor 2. Finally, f of ax is a horizontal stretch. Taking a equals 2, f of 2x equals the quantity 2x squared, which equals 4x squared, and the curve squashes inward toward the y-axis, a horizontal stretch by scale factor 1/2. Before we combine two of these, predict this. If you needed to turn f of x equals x squared into 2 times f of x plus 1 minus 3, what order should you apply the shift, the stretch, and the second shift in? Work from the inside outwards, just like order of operations. Start with x squared, then replace x with x plus 1, giving the quantity x plus 1 squared, a horizontal shift left by 1. Next, apply the vertical stretch, multiplying the whole expression by 2, giving 2 times the quantity x plus 1 squared. Finally, apply the outer vertical shift, subtracting 3, giving the final result 2 times the quantity x plus 1 squared minus 3. So the correct order is horizontal shift first, since it sits inside the bracket, then the vertical stretch, then the vertical shift last, since it sits outside everything else. Full process. Step 1. Identify the domain and range by reading the x values and y values directly off the graph. Step 2. For a composite function, work from the inside out, evaluating the inner function first. Step 3. To find an inverse, write y equals f of x, swap x and y, then rearrange for y and check the function is 1 to 1 first. Step 4. Remember the graph of f inverse of x is the reflection of f of x in the line y equals x. Step 5. For a single transformation, identify whether it is f of x plus a, f of x plus a times f of x, or f of ax. Step 6. For combined transformations, apply them working from the inside of the bracket outward. Watch out! The most common mistake is applying combined transformations in the wrong order, especially mixing up a shift and a stretch. Always deal with what is inside the bracket before what is outside it. Simplified version. Domain is the inputs allowed, range is the outputs produced. Fg of x means do g first, then f. To find an inverse, swap x and y, then rearrange, and the function must be 1 to 1. The graph of f inverse of x is the reflection of f of x in the line y equals x. F of x plus a shifts up, f of x plus a shifts left. A times f of x stretches vertically, f of ax stretches horizontally, and when combining transformations, always work from the inside of the bracket outward.